Hello everybody, my name is Uzay Emir from Purdue University. Today I'm going to introduce you 2022 ISMRM Reproducibility Challenge that we conducted. Our topic is ultra short echo time phosphorus spectroscopic imaging using novel Rosette K-space trajectory at 3 Tesla. Reproducers are from Frankfurt University, Dr. Pilatus, Dr. Alcicek, and Dr. Craig-Craven from University of Bergen. So why do we need to use the phosphorus spectroscopy for the reproducibility challenge? I think we need to remember that phosphorus spectroscopy is the first human MRS methodology that has been used non-invasively. Also, we need to remember that MR spectroscopy of phosphorus is the first method that has been used for the disease in early 1980s. Although it is the oldest methodology, yet still unattractive. So why phosphorus spectroscopy is still unattractive? There are multiple reasons for that. First of all, lack of technical development and integration into the clinical MRI systems. Also, phosphorus spectroscopy is suffering from the low signal-to-noise ratio. This has a consequence of having a poor spatial resolution and resulting in long acquisition durations. On the other hand, we have also lack of processing software available for automated quantification metabolites. So what we aim in this study is to make phosphorus spectroscopy most attractive MR spectroscopy method. To do that, we aim to increase the signal-to-noise ratio, we aim to increase the resolution, and we aim to reduce the acquisition duration together with providing automated quantification methods. We pick ultra-short echo time spectroscopic imaging technique using novel Rosette K-space trajectory. So how did we reach out our reproducers? First of all, we register our reproducibility challenge topic to the ISMRM challenge website. Then following this registration, we posted our reproducibility invitation to the MRS Hub website. Then we posted the same invitation with the available links through the social media accounts. Then we also generated a GitHub website in which we put our invitation together with our findings as well. In addition to that, we created a data sharing platform provided by the Purdue University in which we share our source codes and acquired data throughout this website. Once we identify the reproducers, we conducted our experiments on different sites. 5 healthy volunteers were scanned at each site, and these sites were consisting of 2 Prisma 3 Tesla scanner and a PET MRI. Only Purdue University used the surface coil. So at the end of the study, we demonstrated an MRSI acquisition with an acquisition delay of 50 microseconds. And the replication study demonstrated that this highly accelerated technique has improved the phosphorus spectroscopic imaging. Also, acquiring ultra-short echo time improved the LC model fitting. And we demonstrated that we can achieve similar metabolite maps in healthy subjects. High resolution with an excellent spectral quality was consistently achieved with negligible baseline and phase distortion, and 3 successfully demonstrated a coefficient of variance of around 10% for total ATP creatine ratio. As illustrated, you can see the 4 times accelerated spectra and also metabolite distribution with 3 different acceleration, 2 different sites successfully achieved. According to the reproducers, only a minor limitation has been identified, which is the offline processing pipeline. But the reproducers also mentioned that this pipeline was straightforward and convenient. At the end of this study, the outcomes of this challenge attest the basic efficacy and reliability of the proposed acquisition technique and processing pipeline. This reproducibility challenge make the phosphorus spectroscopy a clinically viable option. Now, it is appropriate to develop and evaluate new protocols that could be suitable for the clinical practice and use them to investigate metabolism. So what we achieve at the end of this study is increased SSNR, increased resolution, short acquisition duration, and automated acquisition and quantification technique. So what we challenge this is later on in the liver and cardiac phosphorus spectroscopic imaging as illustrated below. As for references, I would like to highlight first two is the first MRS method that has been used in humans and disease condition, and the last three are Rosette K-space trajectory that has been developed at Purdue University and used for phosphorus spectroscopic imaging. Thank you so much.